All right, let's dive into a world that you might think you already know, but get ready for some surprises.
Yeah.
Today we are tackling Edward Frankel's Love and Math, the heart of hidden reality. And
Right.
let me tell you, this book, it throws open the doors to like a whole new dimension of mathematics.
It really does.
Yeah.
It's like Frankel argues that what we typically learn about math is like just learning how to paint a fence.
Oh, I love that.
It's useful.
Sure, it's a skill.
But it doesn't even scratch the surface of the beauty and power that math truly holds.
It's such a fantastic analogy, and it
Yeah.
makes me wonder, like, what am I missing out on by only knowing, just the very basics of math? What is all this amazing stuff happening beyond the fences?
Well, Frankel points out this interesting paradox. Math is literally woven into the fabric of our daily lives.
Okay.
Every time you buy something online or your GPS guides you somewhere, it's math doing the heavy lifting behind the scenes.
But we really rarely think about it that way.
Exactly.
We just take it for granted.
Exactly. And that invisibility leads many people to think that math is just too abstract and complex for them to grasp.
Right.
Frankel argues that this isn't because we're incapable of understanding it, but because the way math is often taught focuses on rote memorization and formulas
Yeah.
rather than revealing the captivating concepts underneath.
So instead of being presented as this fascinating language that unlocks the universe,
Yeah.
it's often reduced to just like, homework.
Precisely. Imagine trying to appreciate art if all you ever learned was how to mix paint.
Right.
You would miss out on the emotions, the stories, the profound ways that art reflects the human experience.
Yeah. And Frankel is saying that we're missing out on the same kind of depth and wonder when it comes to math.
Absolutely.
So how do we start seeing beyond the fences and into this hidden world?
Well, Frankel suggests we need to shift our perspective. He emphasizes that math isn't just a tool.
Okay.
It's the language of nature itself. Think of the Fibonacci sequence, for example.
Ah, yes, that famous sequence where each number is the sum of the two before it. Okay, I remember that much from school. But what's so special about it?
What's fascinating is that this seemingly simple mathematical pattern pops up everywhere in nature, from the spiral arrangement of sunflower seeds to the branching patterns of trees. Even the way galaxies are structured follows this mathematical rule.
Wow, I had no idea. That's a perfect example of how math isn't just this abstract thing confined to textbooks.
Right.
It's actually the code underlying the beauty and order we see in the world around us.
And once you start seeing math in this light, it unlocks a whole new level of appreciation for the universe.
Okay, so we've got this intriguing idea that math is the language of nature. How does that translate into actual scientific discoveries?
Think about Einstein and his theory of relativity. He didn't just stumble upon the idea of curved space-time. He used math to envision it. He essentially took the work of another mathematician, Bernhard Riemann, and used it to make a conceptual leap that revolutionized physics.
Oh, that's mind-blowing. It's like math gave Einstein this sixth sense to perceive something that was completely beyond our everyday intuition. Makes you wonder what other hidden realities might be out there just waiting for the right mathematical lens to reveal them.
And speaking of mind-bending mathematical concepts, Frankel introduces us to something called the Langlands program, which some have called a potential grand unified theory of mathematics.
Ooh, a grand unified theory. That sounds ambitious. What's the basic idea behind it?
At its core, the Langlands program aims to connect seemingly disparate fields of mathematics,
Okay.
like algebra, geometry, number theory, and even quantum physics.
Wow.
It's like discovering a secret network of tunnels that link continents we thought were completely separated.
So it's saying that instead of each area of math existing in isolation, they're all interconnected in ways that we never imagined. That's incredible.
Yeah.
But how on earth do you even begin to find those connections?
Well, that's the brilliance of the Langlands program. It uses sophisticated mathematical tools and concepts to create a kind of Rosetta Stone for mathematics, allowing mathematicians to translate ideas and insights across different fields.
Okay, that's a pretty powerful analogy. A Rosetta Stone for math. That's got to be leading to some incredible breakthroughs, right?
It absolutely has. The Langlands program has already helped solve long-standing mathematical mysteries and led to groundbreaking discoveries. It's even revealing connections between math and quantum physics, shedding light on some of the most fundamental questions about the nature of reality.
Wow, okay, now I'm really hooked. We've gone from painting fences to unlocking the secrets of the universe. But I have to admit, while all of this is incredibly fascinating, I think a lot of our listeners are probably wondering, how does this high-level math actually impact my life?
That's an excellent point, and Frankel addresses it directly in the book. He argues that mathematical illiteracy can have serious real-world consequences.
Interesting. I wouldn't have immediately connected those two things. What kind of consequences are we talking about?
Well, he points to the global economic crisis as a prime example.
Okay.
He explains that complex mathematical models were widely used in financial markets, but many of the decision makers didn't fully understand how these models worked.
So it's kind of like they were flying a plane without really knowing how to read the instruments.
Exactly. And as we saw, that lack of understanding can lead to catastrophic consequences that ripple through the entire system.
Okay, so that's a pretty stark example of how not understanding math can have real-world impacts. But are there other, perhaps more subtle ways that math affects our lives?
Frankel also highlights the importance of understanding the mathematical models and formulas used in everyday life. He gives the example of a U.S. government commission secretly altering a formula for the Consumer Price Index, which effectively lowered the reported inflation rate.
Hold on, a secret alteration. That sounds a little shady, doesn't it?
It certainly raises questions about transparency and the potential for manipulation, and it underscores the importance of being able to critically assess the math behind the systems that affect our lives.
So it's not just about becoming mathematicians ourselves. It's about having enough mathematical literacy to ask the right questions and make informed decisions.
Precisely. And that brings us to another important point. Frankel makes mathematics as a source of freedom. He quotes George Cantor, who said, "The essence of mathematics lies in its freedom."
Now that's an interesting idea. How does math equal freedom?
Well, when you understand math, you gain the ability to analyze information rigorously, to break free from conventional thinking and follow the logic wherever it leads. You're no longer just accepting what you're told. You can evaluate the evidence for yourself.
So it's about empowering yourself to think critically and make your own judgments. That's a powerful message.
Absolutely. And it speaks to the transformative potential of mathematics, not just as a subject, but as a way of thinking and engaging with the world.
It's like for us saying, hey, don't be intimidated by math.
Yeah.
It's not about memorizing formulas. It's about unlocking a way of thinking that can help you navigate the complexities of the world.
Exactly. And that idea of math as a tool for understanding complex systems really comes through in Frankel's discussion of the Langlands program.
Okay, let's dig a little deeper into this Langlands program.
Yeah.
You mentioned earlier that it's like a Rosetta Stone for mathematics,
Right.
helping mathematicians see connections between different fields. Can you give us a concrete example of how this works in practice?
Well, one of the key insights of the Langlands program is that there are hidden symmetries and patterns in mathematics that connect seemingly unrelated areas. It's like finding a hidden code that unlocks the secrets of a vast network.
Intriguing. What kind of secrets are we talking about?
For example, the Langlands program has helped mathematicians understand the relationship between number theory, which deals with the properties of numbers, and geometry, which deals with shapes and spaces.
Okay, those sound like very different fields to me. How can they possibly be connected?
That's what makes the Langlands program so revolutionary. It turns out that certain geometric objects can be described using equations from number theory and vice versa. It's like discovering that the same blueprint can be used to build a bridge and a skyscraper, even though they look completely different on the surface.
So it's not just about finding similarities. It's about discovering a deeper underlying structure that connects these seemingly disparate concepts.
Precisely. And this ability to translate between different mathematical languages has led to some remarkable breakthroughs. For instance, the proof of Fermat's last theorem, a problem that had baffled mathematicians for centuries, was ultimately solved using ideas that emerged from the Langlands program.
Wow. So this program is really changing the landscape of mathematics. And you mentioned earlier that it even has implications for quantum physics. That seems like a huge leap. How does math connect to the quantum world?
Well, one of the most exciting frontiers of the Langlands program is its connection to quantum field theory, which is the mathematical framework used to describe the behavior of subatomic particles.
Okay, we're definitely getting into mind-bending territory here.
Yeah.
But game, break it down for me. How can math help us understand the bizarre world of quantum physics?
It turns out that the same mathematical structures that appear in the Langlands program also show up in quantum field theory. For example, there's a concept called quantum duality, where seemingly different quantum systems turn out to be mathematically equivalent.
Quantum duality.
Yeah.
Okay, I'm going to need a little help with that one. What does it mean for two quantum systems to be mathematically equivalent? It sounds like we're talking about alternate universes here.
Well, imagine you have two different languages, say English and Spanish. They
Right.
sound completely different and use different words, but they can both be used to describe the same concepts.
Okay, I'm following so far.
In a similar way, quantum duality suggests that there are different mathematical descriptions of the same physical reality. It's like having two different sets of blueprints that lead to the same building. And the Langlands program provides a framework for understanding how these different descriptions are related.
So it's like the Langlands program is helping us crack the code of the quantum world by showing us the hidden connections between these seemingly different mathematical languages. That's pretty incredible.
It is. And it highlights the profound interconnectedness of mathematics and physics, revealing that the universe is far more intricate and elegant than we might imagine.
You know, the more we explore Frankel's book, the more I'm struck by this sense of wonder and awe. It's like math is this secret key that unlocks a whole new level of understanding about the universe and our place in it.
And that sense of wonder is exactly what Frankel wants to convey. He argues that mathematics isn't just a cold, abstract subject. It's a journey of discovery full of beauty, elegance, and profound insights.
And one of the most fascinating things about this journey is that it's never truly finished. There's always more to explore, more connections to uncover, more mysteries to unravel.
Speaking of mysteries, Frankel poses a particularly intriguing question towards the end of the book. Can we find a mathematical formula for love?
Whoa, hold on a second. A mathematical formula for love. Now that's a deep dive I wasn't expecting. Is he serious?
He is. And while it might sound like a wild idea, it's a question that gets to the heart of what makes math so captivating. It challenges us to think outside the box, to consider connections between seemingly unrelated concepts, and to explore the limits of what's possible.
You know, I have to admit at first I thought that question was a bit out there. But the more I think about it, the more I see its brilliance. It's not necessarily about finding a literal formula that can predict or quantify love. It's about pushing the boundaries of our understanding and embracing the creative, explorative spirit of mathematics.
Precisely. It's about recognizing that math isn't just a set of rules and procedures. It's a language that allows us to express and explore the deepest mysteries of the universe, including the human experience.
And who knows, maybe someday we will find a way to express the complex emotions and connections we experience as humans in a mathematical language. That would truly be mind-blowing.
It would indeed. And it speaks to the incredible power of mathematics to illuminate even the most intangible aspects of our existence.
You know, this deep dive into Frankel's love and math has been really a revelation for me. I've always appreciated math on a practical level,
Right.
but I never truly grasped its beauty and power until now.
It's incredible how Frankel manages to kind of weave together these complex mathematical concepts with personal anecdotes and philosophical reflections. It makes the subject feel really accessible and even inspiring to someone who might not consider themselves a math person.
Absolutely. I think one of the most important takeaways from all of this is that math isn't just about numbers and equations. It's about patterns, connections, and a way of thinking that can be applied to all aspects of life.
And that way of thinking can be incredibly empowering.
Yeah.
As Frankel emphasizes understanding, math gives you the tools to analyze information critically, to question assumptions, and to make more informed decisions. It's like having a superpower that allows you to see through the fog of complexity and make sense of the world around you.
You know, I think a lot of people have this misconception that math is cold, rigid, unforgiving. But Frankel paints a very different picture.
Right.
He shows us the creativity, the elegance, the sheer beauty that lies at the heart of mathematics.
It's like he's saying, hey, don't be afraid of math. Come on in, the water's fine. There's a whole world of wonder waiting to be explored.
And that exploration,
Yeah.
that sense of discovery, is what makes math so exciting. It's not about memorizing formulas.
Right.
It's about pushing the boundaries of what we know
Right.
and venturing into the unknown.
Exactly. Frankel encourages us to embrace the challenge, to unlock our inner mathematicians, and to never stop asking questions.
So to anyone listening who might have had a negative experience with math in the past, I urge you to give it another chance. Don't let those old fears hold you back from experiencing the joy and wonder that mathematics has to offer.
Frankel's book is a fantastic starting point. It's a journey that will change the way you see the world and yourself.
Well said. And on that note, I want to thank you so much for joining us on this deep dive into the hidden world of mathematics. We hope it sparked your curiosity and inspired you to see math in a whole new light.
Remember, the beauty and power of math are accessible to everyone. So go out there, explore, and discover the joy of mathematical thinking.
Until next time, keep those minds curious and keep diving deep.